Hello everyone. This video will be an explanation of project planning and scheduling. Specifically, I'm going to show you the critical path method. In order to fully understand and identify the critical path method, you must first understand how to create a critical path method network diagram. These network diagrams are under this format. Each node is a project, and usually you have the project description written in the center of the box. And for each project node, you have 6 items. So the box is separated into 6 portions, each of which will have a numerical value. To start, on the bottom we write the project duration. I'll mark that with a D. D is the project duration. This is relative to however the situation is defined. So these values could be days, they could be years, they could be weeks, whatever the project implies, and as long as it's kept consistent throughout the diagram. In the above section, we have the project float, which we write as F. Some textbooks also use the letter S for Slack, but essentially it is the same thing. The project float is the amount you can delay a project. We'll get into that in just a moment. The rest of these 4 sections define the start and finish times of this task of the project. You have the early start on the top left, the early finish on the top right, the late start in the bottom left, and the late finish on the bottom right. These 4 give us information about the project start and end times. So the earliest start would be the absolute earliest you need to begin this task in order to make sure the project is completed on time. And follow the same logic for each of these items. So the earliest finish would be the earliest you need to finish the project by in order to finish on time. The latest start is the latest you need to start the project in order to finish on time, and the latest finish is the latest you need to have finished this task in order to finish the project on time. All of that will make sense in the example I give later on, but just understand that logically the earliest you can finish this task will be equal to the early start plus the duration. Same logic follows with the late finish, which would be the late start plus the duration. Notice how I said the float is the amount you can delay the project. Meaning, if you have a clearly defined early start and an early finish, or early start, late start, and early finish, and late finish, then you know the amount you can delay the project by, or sorry, you know the amount you can delay this task by and still have the project completed on time. So the float will be the difference between either the late start minus the early start, or late finish minus early finish. So in other words, take one of the start or finish times on the bottom and subtract it by the associated value on the top. This will give you the project float. Alright, so let's do an example here. So you are to create a critical path method network diagram and determine the start and finish times of the project activities listed in table 1. Also determine the critical path. So it's basically asking us to create a network diagram and to identify what is the critical path, and then it's giving us a table giving us the information about the project which is divided into tasks from A to L. So the first step is to create your activity and nodes, create your network diagram. So I'll run you through the logic as I go along, but here's what we have. We have activity ID, we have a description of the activity, then we have a column that tells us if the activity is preceded by another activity, which means that it has a first step that needs to be completed before you can move on to it. So for instance here, activity B is preceded by activity A, which means that you need to complete activity A before you can start activity B. And finally, you have duration in days of each of the activities. This will be useful information for us to create and fill out our network diagram. So the way I like to start this is first identify what is my independent activity, which is the one that is not preceded by anything. So activity A does not have a required activity for it to start, so I'm gonna start by just putting it on the left side. Activity A will be my first rectangle. From here, what I do is I look to group every activity that is preceded by A. You can see we have 3 here. Activities B, C, and D all require A to be completed for them to start. So because there's 3 activities that require activity A, therefore I will draw 3 arrows pointing out of the rectangle of activity A. And I will mark them B, C, and D. Alright, from then I can move in an organized fashion, and any activity that is preceded by only one activity is very easy to draw because you just draw them as a straight line. So as you can see, if we're gonna do for activity B, let's count how many activities require, or how many activities are preceded by B. I see only one. It's activity E. So I'll draw it as a straight line. Okay. And then how many activities require activity E if we're to follow along on this path? I see one once again, which is H. Next, let's do activity C. Once again, only one. It's activity F. And I see only activity I requires activity F. Moving on to D, only activity G requires activity D. So again, it's another straight line. And with the same logic, you have J following suit. We have activities K and L left. I see that K requires H, I, and J, and I can see how that fits into our diagram. So I'm gonna draw a combining array here that leads into activity K. So the fact that these three lines converge here to go to activity K implies that activity K requires all three of these to be completed. Activity K can only start once activities H, I, and J are all completed. Lastly, we have activity L that only depends on activity K. Okay, and now we can start filling in our rectangles. So I'll start with just going with the only piece of information that I actually have, which is the duration. I'll fill that in exactly as it's written. Alright, I cleaned this up here a little bit to make it easier. But let's start with filling this in. So keep in mind we have the duration in days on the bottom. Alright, we'll start with our independent activity, activity A. Logically, because this is our first activity, we will say that the earliest start, because this requires nothing before it, we can start this immediately, right? This task. So the early start for activity A will be immediately. So day 0. That is the earliest we can start activity A. If the early start for activity A is 0, well then you know that the earliest finish for activity A must be 0 plus 2, because that's the duration, right? If we start on day 0 and activity A has a duration of 2, that means we finish on day 2. So I will put 2 as the earliest finish. Remember what I said. Activities B, C, and D all require activity A to be completed before they can start. So logically, if the earliest we can complete activity A is on day 2, then the earliest we can start activities B, C, and D is also on day 2. None of these activities can be started any earlier than this because they need activity A to be completed. And obviously we won't put a number greater than 2 because that wouldn't be the actual earliest you can start these activities. So I will mark day 2 as the earliest start for each of these activities. Let's go down the path of activity B. So if the start of activity B in terms of the early is on day 2 and the duration is 1 day, that means the earliest we will finish is on day 3. It means the earliest we can start activity E is on day 3. We complete it 2 days later, which means we complete it on day 5, the earliest. Means we can start activity H only on day 5, and it's completed 1 day later, on day 6. Can we still continue down this path and go activity K? We cannot do that yet. We don't know, because activity K also depends on activities I and J, which we don't understand yet. So let's go back to activity C and continue down this path with the same logic. So 2 plus 2 is 4. Now put 4 here. So activity F, the earliest finishes on the 14. 14 here, plus 1 is 15. Same thing here. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 1, 6. Okay, now let's talk about activity K. So you have activity H and J finishing on day 6, and activity I being completed on day 15. So when can I start activity K? What is the earliest I can start activity K? Well, activity K needs all 3 of these to be completed. What is the earliest date that all 3 of these are completed? It has to be on the 15th day, right? And if you ever get confused here, ask yourself what happens. You can start with the lower number. So let's say on day 6, what happens? Okay, by day 6, activity H is completed. Activity J is completed. But activity I is not yet completed. Therefore, activity K cannot start yet. This only happens on the 15th day. So activity K, the earliest we can start it is on day 15. This means that the earliest we can finish it is on day 17. And activity L will start on day 17, the earliest, and finish on day 18. This is the project duration. Now we know how long the project will take to be completed. It is 18 days. That is the entire duration of the project. And now we shall compute. We computed all of the early starts and early finishes. Now we shall compute the late starts and late finishes. For the early start and early finish, we computed this chronologically. We worked from the start to the finish. In order to compute the late start and finishes, we will do the opposite. We will go backwards. So we will start with our last activity, which is activity L. And the logic behind this is that if we're going to start each of these tasks the latest possible, well, we still want to complete the project within 18 days. Any more than that, and we would be unnecessarily delaying the project, which we don't have the luxury of doing. So therefore, I still plan on finishing within 18 days. So my late finish for activity L, I'll still put it as 18. I want this project done by day 18, which means I need activity L finished by day 18, the latest. Working backwards, if you subtract 1 from 18, it means the latest start is on 17. So if I want to have this completed by day 18, I need to start on day 17. That means I need activity K finished by day 17 in order to be able to start activity L by day 17. So I will have 17 here. That's the latest activity K needs to be finished is on day 17, minus 2, the latest it needs to start, is on day 15. Activity K depends on activities H, I, and J, as we know. If I am planning to start activity K on day 15, that means activities H, I, and J need to be completed by day 15. I will put 15 as the late finish for each of these activities. And we will do our process, which at this point we're familiar with. 15 minus 1, 14. 14 over here, minus 2 is 12. 12 over here, minus 1 is 11. So notice how we're doing the same process, just backwards. 15 minus 1, 14. 14 here, minus 10 is 4. 4 here, minus 2 is 2. 15 minus 1, 14. 14 over here, minus 2 is 12. 12 here, minus 1 is 11. Which brings us back to activity A. So, what is the latest we need to finish activity A? So what is the late finish for activity A? You need to complete activity A in time to start activities B, C, and D. Activity B, in this late format, we're starting on day 11. Same for activity D. Activity C, we're starting on day 2. So, let's ask ourselves the same question, going by the lowest number. So let's first consider day 2. What happens on day 2? If I was to write 2 here, it means that I'll have activity A finished by the second day. That allows me to start activity C on the second day. Activity D and B need to start on the 11th day, which is okay. They will still be able to do that. They will still be able to start on day 11 if we finish activity A on day 2. But what if I was to write 11 here? Okay, that's still okay for activity B and D, but I can't finish activity A on day 11. I needed to start activity C on day 2. So between 11 and 2, 2 is the number I need for activity A. 2 minus 2 is 0. Notice how we return to 0. That should absolutely be the case, always. You should have at least one path where it returns to 0, right? Because here we only have activity A as the independent activity, or the initial activity. You could have multiple initial activities, but at least one of them should return to 0 when you work backwards. All right. Now we can fill in the slacks or floats, which, as you remember, I just take one number from the bottom minus the associated number from the top. So here I could do 0 minus 0 or 2 minus 2, but do not do 2 minus 0. So 0 minus 0 is 0. I'll put 0 as the float for activity A. Activity A cannot be delayed whatsoever. You delay activity A and you're delaying the whole project. Okay, let's fill this in. Activity B, 11 minus 2 is 9. Activity B can be delayed by 9 days. And the rest of that should be plug and play, so let's just throw these in for each of our activities at this point, since we're familiar with it. we have completely filled in our network diagram. This is our critical path network diagram, filled in. Good. The last part of the question asks us to identify what is the critical path. What is a critical path? Well, it's a path that's going to run in our diagram, so from left to right, following the arrows. And this path is the path of the longest duration. Okay. What that is true about this path. It will be the longest duration path of the project. What else is true about this path is that it is a path that there is no item in this path that can be delayed whatsoever. And that makes it very clear. You notice how this middle path, A, C, F, I, K, L, they all have the zero float in common, meaning none of them can be delayed. That's how you know it's a critical path. So it's very easy to tell. You must have a critical path. If there is no critical path, so there's no consecutive, there's no sequential path of zero floats, that's physically impossible. You've done something wrong if that is not the case. So there must be at least one critical path. There can be multiple. All right, we have one critical path here in our case. It is activity A, C, F, I, K, L. That is our critical path. And that is the end of this question and video. Thank you for watching.